Hi guys, so this is actually going to be a video over 10.3 to 10.4, which is going to be talking about maximums and minimums. Okay, so first question we have is we want to find the absolute maximum and minima for this function, but we're only going to be looking on it on a certain interval a to b. So first, just so we can get kind of familiar with what we're looking at this function here, which has this graph. So this is the graph of x cubed plus x squared minus x plus 8. But we only want to look at it between -3 to 0. So we're only going to be looking at, this piece of the graph. So just by looking at the graph, I can tell that we're going to have a absolute minimum here at -3, -7, and an absolute maximum at -1, 9. Okay, so my absolute maximum is going to be at -1, 9. My absolute minimum will be at -3, -7. Now, what we want to do is that we want to look at how do we do this using calculus. So anytime you're asked to find a minimum or a maximum, the first step is always going to be finding the derivative. So first, find the derivative. So for this example, the derivative is going to be 3x squared plus 2x minus 1. Okay, after that, you always want to set the derivative equal to 0 and then solve for x. So after we set it equal to 0, this is actually going to be the same thing as 0 equals 3x minus 1 times x plus 1. So what we get for critical values are going to be when x equals 1/3 and when x equals -1. Now remember, we're only looking at x values between -3 and 0, so we're actually not interested in this x equaling 1/3. So now that we have the critical values, the second step is when they ask you to find the points, they want you to take those values and plug them back into the original function. So not only are we going to plug in our critical values, we're also going to plug in our endpoints. So our endpoint of -3, our critical value of -1, and our other endpoint of 0. So when I plug in -3, I'm going to get out -7. When I plug in -1, I'm going to get out 9. And when I plug in 0, I'm going to get out 8. Now, if we didn't have access to a computer graphing system, what this tells me below is that I'm going to have the point -3, -7, which I do here. I'm going to have the point -1, 9, which I do here, and the point 0, 8. Now, I could have just pieced these together, like so, and seen, oh, this is my lowest point, and then this is my highest point, and this endpoint here is nothing. So that's how we could have gotten the answer if we didn't have access to a calculator. Now, the next question is a word problem. So I'm going to try to figure out what my revenue function is. So first, I'm going to lay out the number of units, the price per unit, and the revenue. So if they run out all 50 units, then each unit is going to be $800 each, and the revenue is going to be, well, the number of units times the price per unit. Now, if they increase the price by $20, then they're going to lose renting out that 1 unit. So the revenue is going to be 49 times that 820. So if they increase the price another $20 to 840, then they're going to lose another unit, and their revenue will only be 48 times 840. Now, if we keep doing this, we're going to end up with 50 minus x. So x is going to be the amount of vacant units. The price, well, it's going to be 800 plus $20 times x. That means the number of vacant units. And then the revenue is going to be the number of units they rent times the price per unit. Now, revenue is equal to that guy, and if we expand it out, that would be negative 20x squared plus 200x plus 40,000. But remember, they didn't ask us to maximize revenue, they asked us to maximize the profit. So the profit that they make when they rent out X units is going to be the revenue minus the cost per unit. So it cost them $12 per unit rented, so that would be minus 12 times X. Now, what we need to do is we want to maximize this profit, so we want to take our profit function, and remember, anytime you see the word maximize, that means you're going to have to find the derivative and then solve for x. So our profit function is negative 20x, that's this guy, plus 200x minus 12x is going to give you 188x, plus 40,000. We're going to take the derivative, so that'd be at negative 40x plus 188. Okay, now, whenever you're asked to find a minimum or maximum, after you take the derivative, you want to set it equal to 0 and solve for x. So, after we set this equal to 0 and solve for x, we're going to get that x equals 188 over 40, 4.7, which we should probably round that up to 5. So that means we should leave 5 units vacant. And if 5 units are vacant, that means that we have increased the price for $20 5 times. So that means that we should charge $900. Okay, great. Now, for the next problem, a developer plans to fence in a rectangular region and then divide it into 4 identical rectangular sides by putting fences down the middle. The outside boundary of the fence costs $20 per foot, and the fence for the middle is going to cost $8 per foot. Each lot will contain 10,000 square feet. Find the dimensions of each lot that yield the minimum cost for the fence. So, first I'm going to draw a picture. So we're also going to have these middle fences. Good. And now I'm going to say that this length is x. And then I'm going to say that this length is y. So y, 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 y. Now, here's the deal, is that they said that the outside fences are going to cost $20 per foot. So that means that this fencing is going to be $20 per foot. So the cost is going to be $20 times, well, let's see, we're going to have 1, 2 of those x lengths plus 1, 2, 3, 4, 5, 6, 7, 8 of those y lengths. So that's just the cost of the outside, right here. Then it says it has a different cost for the inside. So for the inside, it's going to cost $8 per foot. 1, 2, 3. So that's going to be $8 times 3x. Okay, so remember, that's cost for the outside. Now here's the deal. We want to minimize the cost for the fence, which means we're going to want to take the derivative of this function. The issue is that we have 2 variables. We have x and a y. So let's see if there's any more information that can help us out here. Oh, each lot will contain 10,000 square feet. So since we're dealing in square feet, that tells me that the area of each piece, which is going to be x times y, is going to equal 10,000. So what this means is that the area of just one of these lots is going to be 10,000. What that tells me is that y is equal to 10,000 divided by x. This is going to help me change this cost function into a single variable. So I'm going to have the cost, which, if I expand this guy out and simplify it, is going to be 64x plus 160y. I can substitute this in for this y, so what I get is that I get a cost function only in terms of x, which is going to be 64x plus 160 times 10,000 divided by x. Awesome, now I need to take the derivative, which is going to give me 64. Well, that's actually going to be a minus. Boop. Minus, and then this guy is going to be 1, 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. X to the negative 2. Okay, so I need to move that negative 64 over. Okay, and then I'm going to multiply both sides by x squared. So that'll give me negative 64 x squared equals negative 1,600,000. Then I'm going to divide both sides by 64 and take the square root. That's going to give me about 158.11. So my x has to be 158.11, and my y value will have to be about 63.25. And the way I got that is because I plugged in that 158 into this equation here. So x has to equal 158.11 and y equals 63.25. Great. Now for the next one, the rate at which the photosynthesis takes place for a species of photoplankton is modeled by this function where T is the light intensity measured in thousands of foot candles. For what light intensity is P maximized? So again, I drew a graph of this, and we see that it's going to be maximized, looks like it's going to be maximized when T equals 2, okay? And then we will get a photosynthesis of 20. So T equals 2, P looks like it equals 20. But how do we prove that that's actually the right answer? So, again, anytime you're asked to maximize something, you want to take the derivative. So P prime of T is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, if I simplify that out, so expand it, put like terms together, I'm going to get 100 times negative t squared plus 4 divided by t squared plus t plus 4 squared. Now, remember, what you want to do is that you want to set this derivative equal to 0 and then solve. Now, whenever you set a fraction equal to 0 and solve, remember, you can just ignore the denominator and just set the top equal to 0 and solve. The reason for that being is that the bottom is never going to equal anything. That would make the whole thing 0. You're not allowed to divide by 0. Only the top will give you a 0. So that means 100 times negative t squared plus 4 has to equal 0, which means that our t-value has to equal 2, which is exactly what we surmised when we looked at the graph, because we are so smart.